All right, so here is an example of a slightly harder problem. This problem's a little weird, but we're going to do it anyway, okay? An unknown mass is hanging from two spring scales as shown. Okay, the left spring scale reads 3.5 and makes an angle of 29, okay? And the right spring scale reads 9.2 and makes an angle of 70 degrees with the horizontal, all right? And we'd probably be looking for the mass. So anytime there's something hanging from multiple ropes, right, you kind of want to do this force diagram around that connection point where they all sort of connect. All right, so downward, I'm going to have the force of gravity, which is basically the weight of this little thing that's hanging. All right, and then I'm going to have Ft, I guess I'll call this one Ft2, and then I have this other one Ft1 that's a little bit less angle. Okay, this is not super to scale. Okay, so Ft1, something like this. All right, so here's my axis. Okay, so the first thing I want to see is that I have two things that need to be split into components. All right, so my Ft2 is going to have an Ft2x and an Ft2y on a 70-degree angle. Okay, so Ft2x is going to be Ft2 cos 70. And Ft2 sine 70 will be the y component, all right? And you don't necessarily have to always draw this picture, right? As you get better at it, you might just be able to see it and write the components, okay? All right, similarly on this side, right, I have my Ft1, so it's going to have an Ft1y and an Ft1x, so Ft1x. Again, it's giving me the horizontal angle, okay? So then I'm going to say Ft1 cos 29, and Ft2y is Ft1 sine 29. All right? Okay, so the secret step that you need to do that is super, super important is redraw with the components. All right, so I'm going to have Fg this way, all right? And then upwards, right, I can see both of these components are upwards, all right? So here I might, well, I probably shouldn't stack them anyway still. I don't really like that. Okay, so I'm going to have my Ft2y and my Ft1y this way. Okay, then I'm going to have my Ft2x and my Ft1x this way. All right. I know that this is not moving. All right, so these are going to have to balance. So left and right, I can see these are going to be the same. Okay, but then up and down, right, both of these tensions pulling up are going to balance out the Fg pulling down. Okay, that's kind of like just like what we did in the stations, little stations activity. Okay, so once I have this drawn, all right, I'm going to do my sum of the forces in the x is 0 and my sum of the forces in the y is 0. All right. I'll go ahead and do this direction. All right, so I'll do Ft2x minus Ft1x equals 0. Okay, so I can see these are going to be equal. All right, so in this problem, right, both of these are known. Okay, so this one's going to be Ft2 cos 70 and Ft1 cos 29. All right. And this usually doesn't happen, right, as you'll see in the next problem. But in this case, everything here is known. So this is kind of a wasted step, right? I don't even really need to do this because this is kind of unnecessary. All right, but if you look at this and I plug in these values, okay, I can see that these both come out to be about 3.1 newtons. Okay, so that's just, you know, that is true. All right. So those are going to be equal. All right, so that's kind of unnecessary here. This is where it's going to get more complicated later. But for this one, you kind of don't even need to do that because it's not even relevant. Okay, because it's asking for the mass. All right, so really what we care about is Ft1y plus Ft2y minus Fg equals 0. All right, so notice I did, oops, that is up plus that is up, right? So I have to add those because those are both up minus the one that's down equals 0. Okay, so I'm going to put Fg over here because that's what I'm really going to be solving for. Okay, so Fg is going to be my Ft1 sine 29, nope, sine 70, plus Ft2 sine 29. Okay, and then I can just plug in what I know. So my Ft1 was 3.5 newtons, sine 70, plus 9.2. No, that's not right. What am I doing? I was right. I'm sorry. Distracted. I was right the first time. 29, I did call 1, right? Yeah, sine 70. Sorry about that. Sine 29, and my FT2 is 9.2 sine 70. Okay, so let me just get some numbers for that. I'm just going to punch it all in my calculator. You're going to make sure that you're in degrees. 3.5 sine 29 plus 9.2 sine 70. Okay, and I get 10.34 newtons is the FG, which is the weight, okay? But I know that that is going to be equal to mg, so I'm just going to divide by g. Okay, so 1.03 kilograms. Okay? All right, good.